Okay, in lesson 9, our objective is to fluently multiply multi-digit whole numbers using the standard algorithm to solve multi-step word problems. Now, word problems are a continual problem with a lot of students, and we're going to have to use some drawings in order to really make sure we're answering the question that's being asked. And that's the biggest problem I see from year to year. Our students end up answering a question that's not being asked. So let's see what we can do. On question 1, says Jeffrey bought 203 sheets of stickers. Each sheet has a dozen stickers. He gave away 907 stickers to his family and friends on Valentine's Day. How many stickers does Jeffrey have remaining? Now, the first time we read it, it was just to get the gist on what was going on. This time, I'm gonna circle important information, and I'm gonna underline what is being asked. Jeffrey bought 203 sheets of stickers. That's important. Each sheet has a dozen stickers. He gave away, 907 stickers to his family and friends on Valentine. How many stickers does he have remaining? Okay. So now I want to sit there and do a drawing. And I'm going to use a tape diagram. And I really suggest a lot of you start get used to using tape diagrams because we're going to see them all year. Now, a tape diagram usually always represents on top would be total stickers. Now, in order to figure out the total stickers, I can see up here it says she bought 203 sheets of stickers. So I'm going to put one sheet here. And I'm going to put this arrow going this way, and I'll write 203 to right here. And that's representing 203 segments on this tape diagram. And he says each sheet has a dozen stickers. So I know each sheet has a dozen, which is 12 stickers. So I can tell, in order to solve for this, up here, I know I'm going to take 12 times 203. So I'm going to come over here, use the standard algorithm, 203 times 12. I'm going to start with my 2, and I'm doing 2 times 3, which is 6, 2 times 0, which is 0, 2 times 4 is 4. So I know now that 2 times 203 equals 406. Now I'm going to multiply my 10. But I'm going to put as a placeholder down here. So now instead of multiplying by 10, I'm just multiplying by 1. So now we go 1 times 3 is 3, 1 times 0 is 0, and 1 times 2 is 2. Notice how I'm lining up my place values. Now I'm going to add these two partial products. We have 6, 3, 4, 2. So I know the total stickers equals 2,436. So I'm going to go ahead and draw this down here now. Another tape diagram. And I know there's 2,436 stickers here. Now, according to what they just said, according to up here, says he gave away 907 stickers. Now I'm looking for the remaining stickers. So looking at this drawing, I can see that if I have a total of 2,436 stickers, and I gave away 907, when I subtract 907 from 2,436, that will give me the remaining stickers. So let's come over to this side. We have 2,436, and I'm subtracting 907. So 7 cannot be subtracted from 6, so I'm going to regroup. I'm going to take 110, and I'm going to make 10 ones of it, and 10 ones plus 6 ones gives me 16 ones. So now 16 minus 7 gives me 9. 2 minus 0 gives me 2. 4 minus 9, I cannot take 9 from 4. So I'm going to regroup one of my thousands, and I'm going to come up with 10 hundreds. 10 hundreds plus 400 gives me 14 hundreds. 14 minus 9 gives me 5. And 1 minus nothing gives me 1. So I can see that we have 1,529 stickers remaining. Question 2 says, during the 2011 season, a quarterback passed for 302 yards per game. He played in all 16 regular season games. For how many total yards did the quarterback pass? Okay, that was our first one. Now this first part, during the 2011 season, that's data I do not need. A quarterback passed for 302 yards per game. He played in all 16 regular season games. How many total yards did the quarterback pass? So total yards did the quarterback pass. So I'm going to take my tape diagram. And the first thing, it says 302 yards per game. He did 16 regular season games. So I'm going to split this up into 16. And I know there's 302 for every one, but instead of splitting for 16, I'm just going to put 16. And I know each section is 302. That means the total here would be the total yards passed. Now on this one, I can see that if I take 302 yards times 16 games, that's going to give me my answer for total yards passed. So we take 302 times 16. 6 times 2 is 12. We carry our 10. 6 times 0 is 0, plus 1 is 1. 6 times 3 is 18. Now we're going to multiply by 10, but we're going to put our placeholder so we can use a basic math facts. Now we're going 1 times 2 is 2, 1 times 0 is 0, 1 times 3 is 3. We add up both partial products. We have 2, 1 and 2 is 3, 8, and 3 plus 1 is 4. So now we know he passed for 4,832 yards. Now, I want to make sure this is a reasonable estimate. So I'm going to come up here, and I know that I did 302 times 16. Well, 300, I'm going to round to either 300 or 400 is closer to 300. 16 is either 10 or 20, and 16 is closer to 20. So I can see that I'm going to have 3 placeholders, and 2 times 3 gives me 6. So I know that my answer will be approximately 6,000 yards, which that's a reasonable answer. Part B says if he matches the passing total for each of the next 13 seasons, how many yards will he pass for in his career? Okay, here's our diagram again. Now, if we go back over, if he matches the passing total, so what we got from above, the answer we got above, which is 4,832, for 13 seasons, how many yards will he pass for his career? Well, once again, he said 13 seasons. But notice here for each of the next 13 seasons. Well, we're already talking about one season up here. So that's a total of 14. A lot of students make a mistake. They don't read it totally. And it says 13 seasons. But this is 14 because you have 13 next seasons plus one he just finished. So we know that's going to be 14 seasons. And we know from our previous problem that he passed for 4,832 yards. So multiplying those two are going to give us the total passed for his career. So now if we come over here, we're going to do our standard algorithm, 4,832 times 14. 4 times 2 is 8. 4 times 3 is 12. We carry our 10. 4 times 8 is 32. Plus 1 is 33. 4 times 4 is 16, and 3 is 19. We put our place value holder, so instead of saying 10, we're going to go by 1. And 1 times 2 is 2. 1 times 3 is 3. 1 times 8 is 8. And 1 times 4 is 4. We add them together, we end up 8, 4, 6, 17, 6. So he passed for a total of 67,648 yards in his career. Bo saved $179 a month. He saved $145 less than Ada each month. How much would he save? Ada save in 3.5 years. So the first thing I'm going to do is I'm going to go through and I'm going to circle the important information that I need to solve the problem. Bo saved $179 a month. He saved $145 less than Ada. How much would Ada save in 3.5 years? So first thing, I'm going to do a quick tape diagram. And I'm going to split this up. And this one here is Bo per month. And this was $179. In this, I'm putting that Ada saved more per month. So we know that is 145. So the total of these two are going to equal amount Ada saved per month. Okay. So I can tell by the tape diagram, I'm just going to add these two together. 179, 145. 5 plus 4, it should be 9 plus 5 is 14. Carry 1. 8 plus 4 is going to be 12. And 3. So the total amount he saved per month was $324. Now the question says, how much would Ada save in 3.5 years? Well, there's a couple ways of doing this. I know that since this was 1 month that they gave us, I know there's 12 months in 1 year. So there would be 24 months in 2 years. And that means there would be 36 months in 3 years. But it says in 3.5 years. Well, I know since it's 12 months in a year, 6 months is going to be my half year. So that's a total of 42 months. So on a tape diagram, it would look like this. I know that it was 324 per month for 42 months. So I'm looking for the total of that. So the total is going to be 324 times 42. So I'm going to come over here and I'm going to do my standard algorithm. 324 times 42. 2 times 4 is 8. 2 times 2 is 4. 2 times 3 is 6. We're going to put our placeholder in here, so we're multiplying by 4 instead of 40. 4 times 4 is 16. 4 times 2 is 8, and 1 is 9. 4 times 3 is 12. add up all our two partial products. We have 8, 10, carry our 1, 16, carry 1, 3, 1. So according to this, Ada would save $13,608 in 3.5 years, or 3.5 years. Let's do our estimate to see if that works out. 324 is going to be closer to 300. 42 is going to be closer to 40. We know our answer is going to have 3 zeros in it, 0, 0, 0, and 4 times 3 is 12. So our estimate should be about 12,000. He came up with $13,608. That is question number 4. Miss Williams is knitting a blanket for her newborn granddaughter. The blanket is 2.25 meters long and is 1.8 meters wide. What is the area of the blanket? Okay, now we're going to go back through and we're going to read it again, underlining the important information. Miss Williams is knitting a blanket for her newborn daughter. That's great information, but we don't need that to solve the problem. A blanket is 2.5 meters long and 1.8 meters wide. What is the area? Write the answer in centimeters. That's a big one. Most students would give me the answer in meters, and that would be incorrect. So if we did a not a tape diagram, but an area model on this one, and I'm going to split this one up, okay? And it says we have 2.25 meters. So I'm going to go ahead and put this like this. Now this is 2, this is 2/10, and this is 5/100. And the other way, I'm putting 1.8 meters, 1.8. Now I know if I multiply these together, it's going to tell me the area in the blanket, but it's going to give me the area in meters because that's what they are in. So starting over here, I have 0.8 times 5. I'm going to ignore the decimals because we went through and explained how we would get rid of them. We'd sit there and multiply 5/100 by 100 to get rid of the decimal. We'd multiply 8/10 by 10 to get rid of the decimal. So 100 times 10, we'd end up having to divide by 1,000 to put them back in. Since we understand that, we're just going to count how many decimal places. So we're going to start off 8 times 5 is 40. Now I'm looking here, I can see there's 2 place values in behind the decimal point in 5/10, and there's 5/100, and there's 1 in 8/10. So I'm going to have to put 3 decimal places back in. So I end up going 1, 2, and 3. So I know my answer is going to be 4/100. Over here, 1 times 5/100 is going to give me 5/100. 1 times 2/10 is going to be 2/10. 1 times 2 is going to give me 2. Finishing up top, 8 times 2 is 16. And I can see I have 2 place values to put in, so it's going to be 16/100. Now we have 8 times 2 again, which is 16. I have 1 place value to put back in, so it's going to be here. Now I'm going to line these up. Now I'm not going to add them all up at one time. I'm going to add up this partial product and this partial product, okay? So I'm starting off with a 1 and 6/10, 16/100, and 4/100. And I'm going to add these up. The first thing I'm going to do is I'm going to put a placeholder in there so they all have the same. 6 and 4 is 10. Carry my 1. 6, 7, and 8. Put our decimal point in there, and 1. Notice we lined up all our decimal points. So our first partial product is 1 and 8/10. Now our second one, I have 2, and I have 2/10, and I have 5/100. When I add, the first thing I'm going to do is put all my placeholders in there. So when I add them up, it's 2 and 25/100. We add these two partial products together. We can see we have 5, 10, and that'll be 4 and 0.5 meters squared. That is our area. Now, they say they want us to do this in centimeters. So now if we come back up here, do it the easy way, we remember our saying, King Henry doesn't usually drink chocolate milk. Now, unit is meter. That is our main unit of measure, our meter. So we know we're at meter. We're drawing an arrow to centimeters, which is right here. And we can see that that is 2 units away from the meter. And we're going to move the decimal in the direction of the arrow. So if I have 4.05, I'm taking this decimal, I'm going to move it 2 places to the right. And that now our answer is reflected in centimeters. So now we know that 4 and 5 meters squared equals 405 centimeters squared. So the answer is 405 centimeters. Next one's a 3-part problem. It starts with A. Write an expression to find the difference in the maximum area and the minimum area of a New York City high school soccer field. Then evaluate your expression. All right, it says write the expression to find the maximum difference. So we know we're going to subtract in the maximum area and the minimum area of a New York City high school soccer field. So here you can see what they're giving us. They're giving it to us in length and width. And it's asking for area. So in order to find the maximum area, I would have to take the maximum length here and multiply that times the maximum width, because it's looking for the maximum area. So if I'm looking at that now, I'm looking at the maximum length in the New York would be 120 times the maximum width would be 80. Now it says, and the minimum area, because this one right here is maximum. Now we're looking at minimum. The minimum area is going to be, minimum length is 100 times minimum width is 55. Now it says we're going to do the difference. So now we're showing the difference between the maximum and the minimum. Okay, well if we take 120 times 80, we can see we're going to have a placeholder. 8 times 0 is 0, 8 times 2 is 16, carry 1, 8 times 1 is 1, plus 1 is 9. So now we know this is 9,600 minus, over here we have 100 times 55. So we know this is going to be 5,500. So now we can see 9,600 minus 5,500 would give us our difference. Now we got 9,600 and we're going to subtract 5,500. We have 0, 0, 1, and 4. So the difference would be 4,100 yards squared. B. Would a field with a width of 75 yards and an area of 7,500 yards be within FIFA regulation? Why or why not? Okay. Would a field with a width of 75 yards and an area of 7,500 be within regulation? Well, we know that if we take length times width, it equals area. They've given us the area of 7,500 and they've given us the width of 75 yards. They have not given us the length. But in order for me to multiply 75 to get 7,500, I can see that I have to multiply by 100 to get 7,500. So the length would have to be 100. So now if I come up here and look at the minimum, it says within regulation. So I'm looking at the length, and so the length has to be minimum 110. So length is less than minimum of 110. The width is within regulation. So the answer would be they would not be in regulation. And that's because the length is too small. You see what we had to do there? We had to fill in our area formula, put in the known information, and see what we had to do. Now, if I didn't know that this was multiplied by 100, I could change the math factor around and say 7,500 divided by 75 would equal what? And I know to take two zeros away, I'd have to divide by 100. The last problem. It costs $26 to fertilize, water, mow, and maintain each square yard of a full-size FIFA field with maximum dimensions before each game. How much will it cost to prepare the field for the next week's match? Okay, so it costs $26 to fertilize, water, and mow, and maintain each square yard of a full-size FIFA field with maximum dimensions before each game. How much would it cost to prepare for next week's match? All right, so we can see the maximum length. We know length times width equals area. The maximum length is 120. The maximum width is 80. So that's what we have to multiply to find the area. So 120 times 80. We have 0, 8 times 0 is 0, 8 times 2 is 16, 8 times 1 is 8, and 1 is 9. So we know the maximum area here is going to be 9,600 yards squared. Now they say it's going to take $26 per yard. So if you look at our tape diagram, here I got $26 per yard. And we have 9,600 yards. So we can see we have to do 9,600 times 26. Now let's go ahead and do an estimate on this one to make sure it's going to be reasonable. So 9,600 times 26, we know that 9,600 is closer to 10,000 than it is 9,000, and 26 is going to be closer to 30. So I can see I'm going to have 5 zeros, and 1 times 3 is 3. So it's going to cost approximately $300,000. Now let's go ahead and multiply it out and see what it comes to. Okay, let's do it over here where we've got some room. So now we're going 9,600 times 26. Make my 2 a little better there. So we got 6 times 0 is 0, 6 times 0 is 0, 6 times 6 is 36. 9 times 6 is 54, and 3 is 57. Now we're doing our 20. So I'm going to take the 0 out. Now we got 2. 2 times 0 is 0. 2 times 0 is 0. 2 times 6 is 12. Carry our 1. 2 times 9 is 18, and 1 is 19. Adding them up. Um, 14. So according to this, it will cost $249,600. and our estimate was 300, so that is a reasonable estimate.